Welcome to Next Gen Duo, your go-to channel for everything AI. Here, we explore the future of artificial intelligence, break down complex concepts, and show you how AI is shaping the world around us. Whether you're a tech enthusiast or just curious about AI, join us as we dive into the innovations and possibilities of this exciting technology. Artificial intelligence, AI, is a self-taught system that learns directly from data, improving over time through experience and feedback. By analyzing vast amounts of information, AI identifies patterns and refines its decision-making, becoming more efficient at solving complex tasks. There are many ways to build self-teaching programs, but they all rely on three basic types of machine learning: unsupervised learning, supervised learning, and reinforcement learning. Unsupervised learning is a machine learning approach where models are trained on unlabeled data, meaning they don't have predefined output labels or categories. Instead, the model's goal is to analyze the data and find hidden patterns, groupings, or relationships within it. This method is particularly useful for analyzing large data sets to find general similarities or useful patterns among profiles, customer segments, or other types of data that are unstructured or unlabeled. Key concepts in unsupervised learning. 1. Clustering. Clustering is one of the most common techniques in unsupervised learning. It groups similar data points together based on their characteristics. 2. Dimensionality reduction. Dimensionality reduction simplifies high-dimensional data by reducing the number of features while retaining as much meaningful information as possible. 3. Association rule learning. Association rule learning is a method used to find relationships between variables in large datasets, often used in transactional or user behavior data. A priori and ECLA are common algorithms for finding association rules. 4. Anomaly detection. Anomaly detection identifies unusual data points that don't conform to the general pattern of the data. Techniques include isolation forests, Gaussian mixture models, GMM, and k-means clustering by identifying points far from any cluster center. 5. Topic modeling. Topic modeling is used to uncover abstract topics within a collection of documents, often applied in textual data. Algorithms like latent Dirichlet allocation, LDA, and non-negative matrix factorization, NMF, help identify topics by clustering related words in the dataset. Unsupervised learning is an exploratory approach that uncovers hidden patterns in data, making it ideal for profile analysis when we want to group similar users or discover useful patterns without predefined categories. By using methods like clustering, dimensionality reduction, association rules, and anomaly detection, it's possible to gain insights into customer segments, behaviors, and trends that can guide data-driven decisions for personalization, marketing, or product development. 2. Supervised learning. Supervised learning is a machine learning approach where the model is trained on labeled data, meaning each training example is paired with an output label. The goal of supervised learning is to learn a function that maps input data to the correct output label, allowing it to make accurate predictions on new, unseen data. Supervised learning is ideal when you have a clear, labeled data set and a specific target you want to predict, such as predicting customer churn, classifying emails as spam or not spam, or forecasting sales. Key components of supervised learning. 1. Labeled data. Supervised learning relies on labeled data sets, where each data point includes an input and a known output. For instance, in a customer profile data set, each row might include attributes and a label indicating whether the customer is likely to churn or not. 2. Training and testing sets. The labeled data set is typically split into a training set used to teach the model and a testing set used to evaluate its performance. Sometimes a third set, called the validation set, is also used during training to fine-tune the model. 3. Features and labels. Features, characteristics or attributes of the data that help in making predictions. Labels, the target variable. The model is trying to predict, like spam, not spam, or high-low purchase probability. Supervised learning involves training models on labeled data to make predictions, often for tasks like classification, predicting categories, or regression, predicting continuous values. After gathering and preparing the data, a model is trained to recognize patterns and minimize errors, then evaluated, fine-tuned, and deployed. For example, a bank might use customer data, such as income, loan amount, and credit history, to train a model that predicts whether a new applicant is likely to repay a loan. This prediction helps the bank make informed lending decisions and reduce financial risk. In summary, supervised learning is best suited for tasks where labeled data is available, and there's a clear relationship between input features and output labels. By training models on this labeled data, supervised learning can make accurate predictions, whether for classification tasks like fraud detection or regression tasks like demand forecasting. Its structured, targeted approach makes it a powerful tool for business applications where predicting specific outcomes is crucial. 3. Reinforcement learning. Reinforcement learning, RL, is a machine learning approach where an agent learns to make decisions by taking actions in an environment to maximize a cumulative reward. Unlike supervised learning, where the model learns from labeled examples, RL works through trial and error. The agent explores actions and learns from feedback, known as rewards or penalties. In reinforcement learning, an agent interacts with an environment, such as a game board or stock market simulation, aiming to optimize its actions within that environment. The environment presents various states, representing conditions or situations. For example, a robot's position in a room, and the agent can take different actions, each leading to rewards or penalties based on the desirability of the outcome. Initially, the agent explores actions at random to understand their effects, exploration. But over time, it starts to leverage its learned experiences to make better decisions for maximizing rewards, exploitation. The goal is to learn an optimal policy, a strategy that guides the agent in choosing actions that yield the highest cumulative rewards. Algorithms like Q-learning and Deep Q networks, DQN, assist the agent in determining which actions offer the best long-term rewards. For example, consider training a robot to navigate a maze. The robot's goal is to reach the exit, and at each step, it decides which direction to move. It receives a small penalty if it hits a wall and a reward when it moves closer to the exit. Over time, The robot learns which actions help it reach the goal fastest by maximizing cumulative rewards, ultimately building an optimal path through the maze. This approach has applications in areas like game playing, where AIs learn games like chess or Go Robotics, where robots learn tasks such as walking or picking up objects, and self-driving cars, where they learn safe driving behaviors by simulating real-world conditions. In summary, reinforcement learning is all about teaching an agent to achieve goals by taking actions, receiving feedback, and optimizing its decisions to maximize rewards. Don't forget to subscribe and click the like button. We appreciate your support and thank you for watching.